Okay, so on your test, you're going to have this situation here like you do with these three. Okay, you're going to have two on your test. Make sure you guys read the directions on the test because there are multiple parts to a lot of these problems. So for example, okay, this wants to know, first of all, is it a poly or not? Yes or no? If it's not, you just write no and you're done. If it is, it needs the degree and the leading coefficient. Okay, so three parts if it's a poly. If it's not, it's just no. Okay, so here we go. First of all, let's talk about what would make it not a poly. What would make it not a poly? If you have letters under a radical, that's not a poly. Okay, anything else you can think of that would make it not a poly? A variable in the denominator, which then leads to the third situation where you have a variable with a negative exponent or a fractional exponent. So it's any of the crazy wonky stuff. So no letters under a radical, no letters in a denominator, no letters with negative exponents or fractional exponents. Okay. So if we look at number one, is this guy a poly? Yeah, he doesn't have anything crazy going on. So he's definitely a poly. Yep, he's a poly. Okay, now you can't just take the first term and tell me the degree and leading coefficient. Why not? What's wrong with his order? He's not in order. He's not in descending order. So you're going to need to, if you were to write him in descending order, and you don't have to, you can just give me the leading coefficient and the degree. But if you were to write him in descending order, this is what he would look like. All right, remember you just take the largest exponent all the way down to no exponent. Okay, so you don't have to rewrite it. You can just pop out the answer if you want to, but that would be rewritten. It does not matter that we have skipped an X. Nope, the only time that matters is with synthetic division. So remember that, we're gonna come back to that point in a minute. Okay, so what is his official degree? 4. He's a 4th degree because that's his biggest exponent. Okay, what is his leading coefficient? Negative 13, because that's the coefficient in front of the letter with the biggest exponent. Done. Does that make sense? Okay. All right, let's look at number 2. First question, is it a poly? No. Why is he not a poly? He's got a letter under there. Now, you don't have to tell me why. I just thought we would discuss it so you would know. So if it's no, you don't have to answer anything. We're moving on. Okay, is this guy a poly? No, why not? He's got a letter in the denominator. So you don't have to answer anything. You don't even have to tell me that's the reason, but I'm just letting you know that's the reason. Sound good? Okay, perfect. All right, here we go. So number 4 says, by observing the graph. What graph, Ms. Holcomb? Well, Ms. Holcomb forgot to give you a graph. Okay, so here we go. What if you had a graph of a little parabola that looked like this? And then let's say this graph for number 5 looks like this. So sorry, you're going to have nice little graphs. Okay, nice little graphs. There you go. All right, because we know if the biggest exponent is a 2, it's a quadratic, which means the graph is a parabola. Okay, all right. So some students don't like this question because it confuses them, right? So the question just wants to know, looking at this graph, is your leading coefficient going to be positive or negative? Some students don't like these inequalities. So what you're supposed to tell me is, because this is opening up, is A greater than 0 or less than 0? He's greater, so you're supposed to answer with this. If that confuses you, I don't want to give you a situation where you're more likely to make a mistake. You can always tell me A is positive, and I'm happy to take that as full credit. If you don't want to do the inequality, some of you guys, that still gets you every time. Okay. All right. What about this guy? What if it's pointed down? What is A going to be? Less than. Or if you would rather just write A is negative, that's fine too. Oh, the study guide's back there. Okay. So whichever one you want. You're supposed to write these, but you can write the words if you want to. All right. Okay, let's look at 6 and 7. Okay, so 6 and 7 are a little different. They're written in different forms. So this is a quadratic written in general form. This is a quadratic written in standard form. Okay. It says determine whether the given quadratic function have a minimum or a maximum value. Then find the coordinates of that point. So let's think about, what are they really asking you? Well, if they have a minimum point, is my graph opening up or down? It's opening up, right? That would give you a minimum. And if it has a maximum point, that means your graph is opening down. So what it's asking you is it opening up or down? And how do you tell if it's opening up or down? We just did it on the page before. Your leading coefficient, right? If A is positive, that's how you know it has a minimum. If A is negative, that's how you know it has a maximum, right? So it's kind of asking you a lot of implied questions. Then it wants the coordinates of this minimum or maximum point. What's another way to ask that question? It wants the vertex of your parabola. So what it's really trying to find out is it opening up or down? And what's the vertex? So that's what it's kind of asking you, but you have to write minimum or maximum, and you have to write the coordinates of the point, okay? So let's look at this first guy here. He's in general form, so he's all stretched out. He doesn't have any parentheses and all that stuff. So if I look at him, is he opening up or down? Down. How do we know he's opening down? He's got a negative A, right? A -1 in the front. So that means he has a maximum. I need to see that word maximum. Don't just say he opens down. I need to know that you know it's a maximum, right? That's what the direction said. Okay, so maximum. Now we want the coordinates of this point, of this maximum point. Okay, since he's all stretched out like this in general form, your vertex, remember, is going to be HK. That's your vertex. To find H in all stretched out form, general form like that, it's going to be the opposite of B over 2A. Okay, so remember, a quadratic is in this form, right? AX squared plus BX plus B. So H is going to be -B over 2A. So here we go. My B is -2, so -B, +2. Then I'm going to have 2 times A. What's my A? -1. Okay, this is going to be 2 over -2. My H is -1. Okay, that's how I found that. Now to find K, I'm going to take my -1 and I'm going to plug in X equals -1 into that original equation. That's how I'm going to find K. Now that you have found your H with your little formula, you're going to have to plug that in. So here I go. I'm going to find F of -1. It's going to be a negative times -1 squared minus 2 times -1 plus 1. Put your little -1 in parentheses there so you don't get confused about all these different signs. Okay, -1 squared is 1. -2 times -1, I'm going to add 2 and add 1. And that is going to give me 2. So my vertex is -1, 2. Okay. So you had quite a bit to do there. You had to know if it's opening up or down, and you had to know how that relates to maximum or minimum. And then you also had to find the vertex, and it's going to be this formula for H. Then when you find H, plug it in the equation to find K. Okay, sound good? All right, now this next one, because it's in this little standard form, is so much easier, so much easier. Okay, first of all, does he have a maximum or a minimum point? He has a minimum point. He's opening up. How do we know he's opening up? Yeah, there's nothing out here. So that means there's a plus out here. If he were opening down, then right here in front of the parentheses, you would see a negative in front of the parentheses, but you don't see a negative there, right? So he's opening up. That means he has a minimum. Okay. Now, when he's in this form, remember, this form is actually x minus h plus k. When he's in that form, you don't have to do any algebra. You just pop your numbers right out. But keep in mind, it's the opposite h, but exactly the same k. So his vertex is not going to be positive 1, positive 1. What's his vertex going to be? Negative 1, positive 1. Good. Okay, so it's going to be the opposite of the h, but exactly what the k is. Okay. What if this were x minus 1? Then what would h be? Positive 1. Okay, so remember, the h is the opposite, but the k is exact. All right, everybody okay on that? There's still no graph. Sorry, I'm letting down the family here over here. Okay, given the graph below, the mysterious graph. Okay, I'm sorry. All right, here's your graph. Now, yours is not going to have a vertex written, but because Ms. Holcomb can't draw, oh shoot, I wanted this to be 3, 1, and I totally screwed that up. Let's pretend that's 1, that's 3. Sorry. Anyway, you're going to have a really nice graph that the computer made and not Ms. Holcomb. And it's going to really clearly be able to give you a vertex. But on the test, you won't have the vertex written for you like this. But you just have to here because I'm really bad at drawing stuff. Okay. All right, here we go. So given the graph below, determine the function's equation. You have to write the equation now. Okay, so we're going to use this equation situation that we had. Okay, that's what we're going to do. And, you know, really, you could put an A out front, just meaning it's either going to be a positive 1 or a negative 1 situation. Okay, so if we were to write the equation on this, first of all, 3, 1's the vertex, which means that h is going to be 3 and k is going to be 1. We take it right from the vertex. Now we need to plug it into this equation. So your equation, now you don't have to write f of x equals, but you know it's always nice, okay, is going to be, what's my a going to be? Is it positive 1 or negative 1? Positive, because it's opening up. Now you don't have to write a 1, it's just understood, but if you want to write a 1, you can. Okay, then my h is 3, so am I going to have plus 3 or minus 3? Okay, and then my k is 1, so what am I going to have on the end? Perfect. Okay, all right, let's try another one. Let's try one that opens down. That's all it wants, functions equation, that's it. Okay, so again, I'm not going to give you the vertex, but because I didn't draw nice graphs on here, I'm just going to tell you what it is. The vertex here is 2, negative 2. On the test, you're going to have to read it off the graph, and it'll be a nice graph. Huh? You're going to have real graphs, yeah, from the computer. Okay, so my h is going to be 2, and my k is going to be negative 2. All right, I'm ready to write my equation. All right, now I'm opening down. So what should be the first thing I write? Negative or negative 1. If you want to put in a negative 1, you can, but make sure that you account for the shape. Is it up or down? It's down, so we're going to do a negative. Okay, my h is 2. So what's going to go in the parentheses? Minus 2. My k is minus 2. So what's going to go outside? Minus 2. What if my h was negative 2? What will go in the parentheses? H plus 2. Okay, so remember, h is the opposite there. No. Okay, everybody good on that? So just standard form for writing that. That's all you got to do. Okay. All right, 10 and 11. We want to know end behavior for 10 and 11. So given this situation here, okay, this poly, what's happening on the end? Is it rising or falling? Okay, now this I'm going to ask you to write the, we're writing out the words, but on your test, you're going to have pictures of graphs, 4 pictures. You just tell me which one the poly matches up to. There's only going to be one that has the right end behavior. So that's all you have to look at is the end behavior. Okay. So let's see if we can remember how to find this. So to find out what's going on the ends, you have to know the degree and the leading coefficient. Okay. You have to know for both. So the first thing you're going to find, paper out here, but okay, let's do, first thing you're going to find is your leading coefficient. Okay, first thing you're going to find is leading coefficient. If your leading coefficient is positive, then it's going to rise on the right. If your leading coefficient is negative, it's going to fall on the right. So the leading coefficient determines the right-hand behavior. Okay, the leading coefficient determines the right-hand behavior. If it's positive, it's rising. If it's negative, it's falling. So that tells you what's going on the right. Okay, then second, you're going to look at the degree of the poly. All right, if the degree is even, it's the same behavior on the left. Now that didn't tell you rises or falls. You have to find out what happened on the right first. And then if it's even, it's the same on the left. If it's odd, it's the opposite on the left. So odd opposite, right? O. Okay. So first leading coefficient, that's going to tell you what happens on the right. And then you look at the degree, and the degree will either say do the same thing over here or do the opposite thing over here, depending on whatever you pick for the right. Okay. So let's think about what this guy is going to look like. Okay, he's already in descending order. I'm not trying to trick you. You're going to already have them in descending order. So the only thing I'm looking at is the first term. That's it. That's all that matters. The first step is the leading coefficient. And it's positive, right? It's a positive 11. So my leading coefficient is positive, which means what's happening on the right? I'm rising right. Good. Then the second thing I'm going to look at is the degree. What's my degree? 4. Is that even or odd? Even. If he's even, what's happening on the left? Same thing that happened on the right. And since the right was rising, so's the left. So this is going to be the answer. So when it comes time for you to find your answer on the test, you're going to have 4 multiple choice graphs. There's only going to be one where they are both rising, the left and the right, and that would be the one that you choose. Now it's going to have all kinds of stuff going on in the middle. I shouldn't make him a parabola. He's probably got all kinds of weird things happening. But there's only going to be one graph where they're both rising, and that's the graph that you pick. Okay, does that make sense? All right, let's try another one. Okay, number 11. He's already going to be in order, so you're just looking at that first term. Okay, your first step is the leading coefficient. Okay, in this case, it's a 5. So what's happening on the right? It's rising. If it's positive, it's rising. So now I'm rising right. Okay. Second step is the degree. What's my degree? It's odd because it's a 3. So if it's odd, what's happening on the left? It's falling. So on the test, you're only going to have one graph where it's rising on the right and falling on the left. And that would be the graph that you pick. Okay. Does that sound good? Now it's also going to have the words there too. So it'll be the only graph that says rising right, falling left. Okay, but it'll show you a picture too. Is that okay? All right. Okay, here we go for 12 and 13. This is going to get a little weird, so we're going to have to really think back to this section before spring break. Okay, number 12 and 13, they want multiple things here. Every question wants multiple things. We want the zeros of the poly. That means the solutions, okay? Then we want the multiplicity of each solution. Then we want to know, at each solution, is the graph crossing through the x-intercept, or is the graph touching it and turning back? Okay, so 3 things for each one. All right, let's just take it step by step. It's already factored for you. You do not have to factor these. So all we're going to do is find the solutions. So here we go. We've got 3 different factors, which means we're going to set each one equal to 0 and solve. This -3 out front, if I set him equal to 0, does he produce a solution? No. Remember, he's just a GCF that was pulled out. If it's only a number out front, he does not produce a solution, because think about that. -3 equals 0, that doesn't even make sense. The only time it matters is go ahead and skip down to 13. Here I have a letter outside. Does that produce a solution? You better believe it. So if there's a letter outside, it's x equals 0. If there's a number outside, forget about it, okay? All right, now let's look at this next packet. If I set this equal to 0 and solve, what does x equal? A -5. All right, what about this packet? If I set it equal to 0 and solve, what does that equal? 2. Okay. No, good question. Okay, so first thing we did, we found our zeros. Everybody good with that? Okay, second question, it wants the multiplicities. Multiplicities are what? Are the exponents. That's all they are. They're just the exponents. So if I look, I'm not going to write multiplicity over. I'm just going to write mult. How about that? Life's too short. Okay. So what is the multiplicity of -5 going to be? 3. Where does that come from? Exponent on his packet. Okay. And everybody has a multiplicity. So what's the multiplicity of 2? 1. If you don't see it, it's 1. Okay, everybody got that? Multiplicities are just exponents. Okay, the third thing they want is the behavior at that 0. So is it crossing through or is it touching or turning? That comes from your multiplicity. If your multiplicity is odd, then it's crossing through. I know that's not how you spell through, but I'm just really lazy with words. That's why I'm a math teacher. Okay. If your multiplicity is even, it's going to be a touch and turn. You can say TNT if you want to, touch and turn. Okay. That's how we know what's going on there. So when I look at -5, what's happening at -5? Are we crossing through or touching and turning? Crossing through, because the multiplicity is odd. Okay, what's happening at x equals 2? Crossing through, because the multiplicity is odd. Joy, do you have a question, honey? You're just stretching? Okay. Oh, okay. So make sure you're not looking at the 0 itself for the odd or even. You're looking at the multiplicity to see what's happening. So that's what's happening at both of these. Okay. Does that sound okay? Now, this part's going to be multiple choice. So all you have to do is pick the multiple choice answer that's right there. Okay. All right. Let's talk about 13. Now, one of the stipulations with a poly for this, when you're doing this stuff, is that it's only for real zeros. I hate this question, but I don't make the test. So this is only for real zeros. So pay really close attention to 13, okay? 13 is gonna look a whole lot like yours, a little more than 12. It's just 12 I wanted to do for practice. Okay, throw a number in front of this for me. Let's make this 2x squared, okay? And then this one is pretty much identical to to what you're going to have on the test. Okay, everybody got it? All right, here we go. First of all, we need our zeros. So we're going to go through and set each item equal to 0 and solve. Okay, I have 2x squared here. Now up here, we just crossed through the -3 because it didn't matter. You can cross through the 2 here if you want to. And then all you're left with is going to be x equals 0. That's what comes from this. If you want to see the math on that, because that looks a little strange, let's do the math. Let's say we have 2x squared. I set it equal to 0. I divide by 2, still 0. I take the square root of each side. Well, plus or minus 0 is just 0. And that's why you end up with a 0. So anytime you have a letter outside, you don't even have to do this. You can just say equals 0 every single time. Forget the number, put the letter equal to 0. This is why, but you don't have to do that if you don't want to do that. Is that okay with everybody? So do you understand that 2x squared is x equals 0? Okay, let's skip this guy in the middle for a minute. What's this x on the end going to equal? 7. Okay. Now let's look at this guy on the inside. I hate this problem. Okay, so let's look at him for a minute. We got a problem here, guys, because look at the x inside the parentheses. He's got a square on him. He's not supposed to have a square. Look, these others don't have a square. Well, if he were x squared minus 1, that would be great. I would say, oh my gosh, he's a difference of squares. I could factor him. But he's not a difference of squares, he's a sum of squares. Can you factor a sum of squares? No. Does anybody know why? Because the answers aren't real. They're not real. Look what would happen if I tried to solve him. If I set him equal to 0, I subtracted 1, I took the square root of both sides. What is the square root of -1? You're imaginary. I'm not allowed to have imaginary zeros. That means that, I'm so sorry they're doing this to you. You just forget about him. He doesn't produce real zeros. Okay, so on the test, be on high alert. Do whatever you got to do on this problem to remind yourself not to use him. Do not use him because he's going to produce imaginary zeros. One of your answer choices, because again, this problem's multiple choice, is going to have those zeros in there, but don't pick that one, okay? All right, so I only actually have 2 zeros. Let's talk about the multiplicities on these guys. Okay, what's the multiplicity for my x equals 0? 2. He's got an exponent, we're going to use it. What's the multiplicity for number 7 over there? 4. Okay, so what's going to happen at those zeros? Am I crossing through or touching and turning? Yeah, I'm doing a touching and turn. I'm just going to be lazy and do that. Okay, now it's a terrible coincidence that it looks like both zeros here were crossing, both zeros here were touching and turning. Yours on your test, I think, is a mix. I think like 1 0 is a cross through and 1 0 is a touch and turn. Okay, and then you have those imaginary ones that you're not going to use. Is everybody okay on that? So just kind of, yeah. Why is it not -3? Oh, because your multiplicities are always positive. It's just going to be whatever your little exponent is. That's it. So yeah, it'll always be positive. It's just whatever's sitting up there. And if you don't see anything, it's a 1. Okay. Anybody else? Good. Okay. All right. Okay, that's a stinky one, but here we go. Okay, we're not doing 15. Yours is going to look like 14. All right, 14 just wants vertical asymptotes. To find vertical asymptotes, you're going to forget about the top. We don't care about the top. You're going to set each factor on the bottom equal to 0 and solve. Those are your asymptotes. So you may be able to do this one in your head. You would add 3 and divide by 2. Okay, good. I know, in this day and age, when you cough, everyone looks at you like, I know, and then I'm always the one that coughs. I'm like, I promise I don't have the venom. Okay, so then you saw this guy and it's -2. So those are your two vertical asymptotes. So it's only whatever's in the bottom. You don't have any holes, you don't have any weirdness, you don't care about the top, nothing cancels. You just do that, okay? I mean, if you really wanted to solve this guy down here, you would just set the bottom equal to 0. It's gonna be x equals 3, but yours is gonna be like that, okay? All right, so vertical asymptotes, forget the top, just solve the bottom. You're ahead of the game. Okay, yeah, you're gonna have both. You're gonna have vertical and horizontal. Okay, so remember, horizontal asymptotes, it depends on the degree, right? The degree of the top and the degree of the bottom. That's what it depends on. So you don't have to worry about 18, but you are going to have to be aware of 16 and 17. So let's see if we can remember the situation. Okay, let's compare the degrees. That's what you do, is you compare degrees. All right, what is going to be the degree of my numerator in this case? 1, right? Because there's just a 1 on the x. What is going to be the degree of the denominator? 2, okay? If the denominator degree is bigger than the numerator degree, your horizontal asymptote is 0. Okay, that's just pure memorization. That's the rule. If the degree in the bottom is bigger than the degree in the top, it's y equals 0. So it has nothing to do with anything else. Okay. All right. Now we look at 17. We're comparing the degrees. What's the degree in the top on this guy? What about the degree in the bottom on this guy? 2. If they're the same, then you're going to take the leading coefficient. So same degrees, use the leading coefficient. So my leading coefficient is 4 in the top and 2 in the bottom. Reduce that, y equals 2. Okay. And then just kind of for your homework, what happens if the degree in the top is bigger than the degree in the bottom? Anybody know that? None. There isn't one. You're not going to have that situation though. You're going to have both of these. Okay. So if degree in the bottom is bigger, y equals 0. If degrees are the same, make a little fraction with the leading coefficient. Reduce it the best you can. Okay. Any questions on that? Okay. All right, let's look at 19. Okay, 19 is going to be multiple choice, but that doesn't make it easy. That makes it, you got to really pay attention, right? With your little young eyes and try to make sure you get everything in there. Okay, so the possible rational zeros, okay, are going to be all the factors of your constant divided by the factors of your leading coefficient. That's what that means, okay? So factors of your constant divided by factors of your leading coefficient. Now, the only time students mess up with this, because usually they do a pretty good job, they forget who's on top. So sometimes they'll put factors of leading coefficients divided by factors of constants. And unfortunately on this test, one answer is going to be this, and one answer is going to have it if you had flipped it. So make sure, do something to help you kind of remember, you know, I mean, I'm always coming up with stupid stuff. Constant, it's like ABC order, right? Constant would come first before leading coefficient. So maybe it goes on top. Come up with something to help you remember that. Okay, what's my constant in this poly? -11. Okay, so we're not going to worry about the sign because we're going to do plus and minus for everything. But my factors of 11, that's just 1 and 11. It's not really anything I can do. What's my leading coefficient? 22. All right, I got a few more for him. So I'm going to have 1 times 22 and 2 times 11. I think that's it, right? Okay, here we go. All right, in my numerator, I want plus and minus every factor of the constant. So plus and minus 1, plus and minus 11. That's it. Okay. My denominator, I want every factor plus and minus of the leading coefficient. And I'm going to put them in numerical order because I'm not an animal, right? Okay. I'm not just going to willy-nilly throw them in there. Okay. Now you're going to have to clean it up. That's not going to be a choice. You're going to have to clean this up a little bit. You can't just go, oh, look, I could cancel this one and this one. It doesn't, you can't do that. Okay. So here's how you do it. You're going to take your first one, 1. You're going to do 1 divided by 1. That's 1. Then you're going to do 1 divided by 2. Okay, that would be 1/2. And then you're going to do 1 divided by 11. That's 1/11. And then you're going to do 1 divided by 22. And then you're done with the 1. Okay, so we just took him and we put him over every single denominator. And now we're going to do the same thing with the 11. So I'm going to do 11 divided by 1. That's 11. 11 divided by 2. Oh, plus or minus. Good, plus or minus. 11 divided by 11, that's 1, and we already have that, so you don't have to repeat. 11 divided by 22 is what? A 1/2, right? That's 1/2, we already have that, so we don't need it. So those are our answers, okay? So that's the one that you're gonna look for. So now you can kind of see when I say that the multiple choice can be tricky because they're gonna have like a million of these little numbers, and you gotta go in there and make sure they're not flipped and make sure they didn't leave anybody out. Okay. Huh? That was 3.3. Right after synthetic division, I think we did that. Or it might have been 3.4, one of those. You know what? I bet you were doing your thing that day that you went and did some other homework. Yeah. Okay. Is everybody all right with that? Oh, yeah, because 11 divided by 11 is 1, and you already have it. And then 11 divided by 22 is 1/2, and you already have that. Yeah, so you just don't have to repeat. If anything comes up repeating, you can just leave it off. And then that's all you got to do. Okay, sound okay? All right, let's look at number 20. Okay. Number 20 is synthetic division. Okay, let's talk about yours compared to the one here on this. Well, let's just go ahead and do this one, and then we'll talk about the one that's going to pop up on the test. Okay, first of all, it's already in descending order. Am I missing a term? No. How do I know I'm not missing a term? It goes in order. The exponents go in order. 3, then 2, then 1, then a constant. Okay. All right. So I'm going to take every coefficient and make a line. And then I'm going to have a shelf. Who goes on the shelf? 3. How do you know it's 3? Yeah, because what you're really doing is setting that denominator equal to 0 and solving for x. And whatever x equals is going to go in that line. You can think of it as the opposite sign, but that's what's really happening. Okay, then we're going to leave a space. We're going to add, and we're going to bring the first guy down. Here we go. We're going to do 3 times 2 is 6. -3 plus 6 is 3. 3 times 3, 9. -11 plus 9 is -2. 3 times -2, -6, and we get a 0. Everybody okay where I got that? All right, now I need to put x's with these. I started with an x to the 3rd. My answer is going to be x to the what? 2nd. You go down a degree. And then I just kind of fill in. I start with x to the 2nd, and then I go to x, and then I have a constant. So my final answer is going to be this. All right, let's talk about yours. Yours is going to have one different situation. And by the way, there's no remainder on yours on the test either. So if you get a remainder, you need to redo it. That's going to be your big hint that you messed up. Why would you get a remainder? Because yours is going to be missing a term. And if you don't catch it when you put your coefficients in a line, you're going to end up with a remainder. So what do I mean by that? I mean, what if your problem, your original problem looked like this instead? What if that was your original poly? What are you missing here? X to the third. So how would you write the line of coefficients? You would write 2, then what? 0, then a -3, then a -11, then a 6. Okay. If you're missing a term, we're missing X to the third, you have to put in the placeholder 0. Okay. And if you do that, you will not have a remainder. So no remainder. Okay. You come up with a crazy, wacky remainder. Hopefully you'll go, oh my gosh, I forgot it was missing a term. So yours will be missing a term. Keep that in mind. You put a 0 in for that, and then you just treat it like normal, right? You do your little shelf with your 3, you bring it down, and you go right on ahead, okay? All right, let's talk about domain. The domain questions never go away. Okay, the only domain question you're gonna have looks like number 22. So remember, for a domain question, you're going to factor the denominator, solve it, and then exclude it, right? You don't want it. You want to leave it out. That's what you're going to do. Okay, so here we go. I don't care about the top. I'm only looking at the bottom. Okay, I need to factor him, but there's really only one thing to do. What is the only thing I can do? He's got a GCF of X, right? If I pull it out, I get X plus 2. If I set each little factor equal to 0, I get X equals 0, X equals -2. Everybody okay with that? Okay, that's actually though what I don't want. I want to leave those out. So if you want to draw a number line, you can, you do not have to. But if you want one, what this means is that you don't want these numbers happening. So you're going to do this interval, unioned with this interval, unioned with this interval. You're leaving them out. You're using parentheses to exclude them. So we're going to have -infinity to -2. Use parentheses because we don't want to include them. -2 to 0, 0 to infinity. And we put the big old fat U's in there. And there's your answer. Okay, so you can certainly practice with 21 and 23. Practice doing that if you need to. Okay, but you're just solving and leaving them out. All right, number 24 is your bonus opportunity. That is your extra bonus opportunity. Okay, so in number 24, you have a poly. Notice he's a 3rd degree. Okay, how many answers should you come up with? 3. Okay, so make sure we got all that. All right. Okay, so number 24, okay, says solve the polynomial. That means give the answers, okay? All you have to do, because, there's not a whole lot of time to take a test, and some of you guys, you like to take your time with it. The required portion is just list the steps. Just tell me what steps would you take to solve the problem in words, and you got the point. If you want extra points though, then do it. You don't even have to list the steps. You don't have to waste your time with the steps. Do the problem and give me the 3 answers. Give me the 3 answers, and that gives you not only full credit, but also bonus points. Okay, so what steps would you need? I put them in the back, okay, just so you would have them. They're back there somewhere. Okay, so this is the steps that you're going to need. Now you can put these in your own words. You don't have to have this word for word, but step 1 is going to be use the rational zero theorem. to find your possible rational zeros. You can call it the RZT if you don't want to write. You know how lazy I am. So what is the rational zero theorem? That's the thing we did with the plus and minus factors on the top and the bottom, right? So step one, you have to use that. Step two, try each one until you find one that works, okay? Number three, use synthetic division to reduce the poly. The key here is synthetic division to reduce the poly. That's the key word there, okay? So we can use rational zero theorem, try each one till you find one without a remainder. Then number four, solve the reduced poly for the other two zeros, okay? Those would be the steps that you would have to take. Use rational zero theorem to find your possible rational zeros. Try each one, you find one that doesn't have a remainder. Use synthetic division to knock it down a degree, and then you solve it to get the other two, okay? If you want to go through and get your bonus points, then I'll come back to that and show you that at the end because I want to get to the required. And if we run out of time, I'll put it at the end of the video and send it out so that you can see it all, okay? Because I want you to be able to do that, but I don't want to take up too much time on that because there's three more I want to get to real quick, okay? And then we'll come back to that. But does that make sense to everybody? So all you have to do is tell me the steps that you take to solve it. If you want to actually solve it, you don't have to write the steps. You can just do it. And then your three answers that you come up with would satisfy everything, okay? All right, so we'll come back to that. You can do 25 for, and you can do 27 for practice, but 26 is what you're gonna have to do. And all you're gonna do here is solve. You don't even have to graph. You don't have to graph them, you're just gonna solve. Notice that he is an inequality. That means you're going to have to find the boundary points. Remember what we did on Tuesday? You have to find boundary points and make intervals and test the intervals. That's what this question is. Okay, so first of all, we need to find boundary points. So that means I have to solve this guy. He doesn't have a GCF. He's not a PST, nor is he a monic. So I got to do it the old-fashioned way, right? Where this is a 12. So I want factors of positive 12 that are going to add to give me 7. 3 and 4, or 4 and 3. Yeah, however you want to do it. Order really doesn't matter. I just put it in this order because it'll come up real nice when you do this. All right, I'm going to replace this plus 7x with those. Okay, all I did was replace it. And then I'm going to group it and solve it. If you like to do it a different way, you do it however you want to do it. Okay, I see a GCF in the first packet of 4x. Pull that out, I get x plus 1. Now I see a GCF in the second packet of a positive 3. Pull that out, I get an x plus 1. Same packet. And then I write what's left. Okay, so all I did was solve that left side. Now, if I set each one of those equal to 0 and solve, I get x equals negative 1. Now this next one, you might have to actually set it equal to 0 and solve it. But what you'd be doing is subtracting 3 and dividing by 4, okay? Those are your boundary points. They're not your answers, right? So then you're gonna make a number line. And here are, and you're gonna have to put them in order. Make sure you realize negative 1 is smaller than negative 3/4. We talked about the fact that you guys can't pick numbers in the intervals. This is a real stinky one because this interval is super tiny. So I'm sorry about that. Your one on your test won't be like that. Okay, so now we're ready. We've got this interval, and this interval. We're gonna have to test them. Your answer will not be no solution and it will not be all real numbers. You don't have to worry about those. Okay, so just so we can go ahead and label it, this interval would be negative infinity to negative 1. Now, what enclosure am I going to give that negative 1? Whatever this is. Whatever this is. So in this case, what am I giving it? Parentheses. I will go ahead and warn you on your test, it's going to be this. And so what would it be on the test that you're going to give it? A bracket. But this is how you know. Okay. All right. This interval is going to be this little guy. This interval is going to be this little guy. So whatever this inequality sign is, that goes for all the numbers, the enclosure for all the numbers. Okay, now we have to test each interval and see what we come up with. I don't have room for a whole big chart. I'm kind of running out of time. So what I'm going to say is let's pick some test points. Okay, I need any point at all, any number at all that's between negative infinity and -1. How about -2? We could test that. Remember that? Okay, so when I say test it, where are we putting it? Back in the original inequality. So I'm going to have 4 times -2 squared plus 7 times -2 plus 3. When I plug it in there and test it, I came up with a +5. Okay, now this original inequality told me that everything on the left is supposed to be less than 0. Is 5 less than 0? No. So that interval is not true. Okay. Now here's the stinky part of this example. I got to have a number between -1 and -3/4. I chose -0.8. Yours won't be anything weird like that. It'll be very clear, nice numbers that you can pick. Okay. So now I'm going to go back. Same original inequality. Plug in a -0.8. Okay. I came up with -0.04. Now remember, the key is everything on the left is supposed to be less than 0. Is that less than 0? Yeah. So that interval works. Okay. Now I got to test this last interval. In this last interval, I need any number between -3/4 and infinity. You know I love a 0. How about a 0? Okay. If I plug in a 0, it ends up being 3 is less than 0. Is 3 less than 0? No. So my whole answer is going to be just this interval, this -1 to the -3/4. Okay, I want to talk about the next problem real quick. We'll just get it set up. Well, we're probably going to run out of time, actually. So what I'll do is I'm going to continue the recording for you. And then when I send it out, I'll tell you what time marker to start watching so that you can get the last 2 problems. And then I'm going to go back and do that other problem so that you can see for the full credit. Does that make sense? Yeah. Okay. Huh? Yes, I'm going to go back and hit 24. Okay. So get some more study guides and get some more donuts. And then I'm going to keep on going and get this recorded. Okay. So make sure you watch it so you get that last problem and then both bonuses. Okay. All right. So we'll let the herd of elephants get out, but I'm going to keep on going. So, okay, perfect. Let me just finish this. Okay. So this is not, there we go. Okay. So 29, you don't have to do. 30 is a bonus. And we're going to do 28. Okay, so here we go. Same thing. We're going to solve the inequality. So we're going to get bonus points, not bonus points, boundary points, make intervals, right? And come up with the answer. But we also want to graph this one on a number line. So we're going to do both. So what we're going to do, since there's a top and a bottom, we're going to solve both. So let's take our top. We're going to set it equal to 0 and we're going to solve it. See you later, guys. So if I subtract 4 to the other side and I divide by a -2, I get x equals 2. All right. Now I'm going to solve the bottom. I'm going to take the bottom, set it equal to 0 and solve. I'm going to subtract 4. And I'm going to divide by 3. -4/3. There we go. Okay, those are the boundary points. So now I'm going to put him on a number line. Here's my number line. -4/3 is small, 2 is bigger, and this makes 3 intervals. Okay, here we go. Okay, now I'm going to go ahead and name my intervals. Here's where it gets tricky because I have a denominator. So first interval is going to be -infinity to -4/3. Now, normally I would just look at my inequality sign. This indicates we want a hard bracket, but it came from the denominator. If it comes from the bottom, you have to use, thank you. You have to use parentheses if it comes from the bottom. If it comes from the top, you're going to use the inequality sign. Okay, so because -4/3 came from the bottom, I'm going to use a parenthesis. Okay, because he's the answer that I got from the bottom. Okay, and now I'm going to label my other two. All right, for this one, I'm going to do -4/3 to 2. Now remember, -4/3 came from the bottom, so it gets a parenthesis. The other one gets a hard bracket because we pay attention to whatever this says. Okay, last interval, 2 to infinity. 2 came from the top, so we get the hard bracket. Infinity always gets parentheses. There we go. Perfect. Okay, now we need to test each interval. Okay, so I need a number between -infinity and -4/3. We want to be careful here. Don't say -1 because that's not in that interval. It's actually, you could pick -2, -3, -4. You can pick anything you want, but it has to be bigger, or I'm sorry, smaller than -4/3. So I just chose -2.
I would say -2.
Good. Okay, now I'm going to test it, which means I'm going to plug it into my inequality.
And you plug it to both?
Yep, you plug it into top and bottom, anywhere you see an X. There we go. And remember, we want this to be less than or equal to 0 because that was the original inequality. So when I work all this out, I ended up with a -4. And that is less than or equal to 0. So I'm going to use that interval. Now I'm going to keep going because there might be other intervals. My next interval, I need a number between -4/3 and 2. You could do 1. I'm going to do 0 because it's easier, but you could do 1 for sure. You'll get this, come to the same conclusion. Okay. So if I plug in a 0 back at the original and test it, I end up with the number 1. But 1 is not.
I see why I see 0 because it like bases it out.
Yeah, it just makes it easier. Okay, so 1 is not less than or equal to 0, so we're not going to be using that middle interval. And then last but not least, I'm going to test is something between 2 and infinity. Yeah. Great, perfect. Okay, so now I'm going to plug in a 3. We want that to be less than or equal to 0. So when we do the math, it actually ends up being this really ugly -2/13. Because this is 4 minus 6, and this is 9 plus 4. It ends up being this. But it is less than or equal to 0. So we're also going to use that interval. So that works.
Use it for anything yet.
Not yet, but we now know both these intervals work. So our answer is going to be both these intervals. Your answer is going to be the intervals. So it's going to be this interval that we said worked in the beginning, unioned with this interval that we said worked at the end. And that's going to be our answer.
So you put the U.
Mm-hmm. And you just put a union between them. With a hard bracket though, because remember, 2 came from the top.
Yeah, I was going
Yeah.
to try to figure out the hard bracket.
Okay. And now this one also wants you to graph it. Now I'm kind of out of room, so I'm going to stick it down here. So to graph this one, all we're going to do is put these numbers back on our number line. And then we're going to put our little enclosures with them facing the right way. So for the -4/3, he's got a parenthesis facing this direction. So there's his graph. And then the 2 has a hard bracket, and it's facing this direction. So we put it on there, and then that's your graph.
Like that.
Perfect. That's it.
And that's what-
It's not bad at all. Okay. The long part is having to do all these little tests.
Yeah.
That's the long part. Okay, let's look at the bonus. So number 30 is going to be a bonus question. You don't have number 29, but you do have number 30. So number 30 just wants to know if you started with this and you ended with this, what kind of transformation did you do? So remember, and it wants the domain and the vertical asymptote. Okay, so to find the domain, remember, that's just your denominator. So in my domain, and he is squared, but that just means there's 2 of them. That would just be his multiplicity, but we don't even need that. So if I set this equal to 0 and solve, I see x equals 3. And remember, for a domain, we want to exclude that. So if I had a number line with a 3 that I did not want to have in it, then what I'm going to do is have this interval unioned with this interval. So my domain is going to be -infinity to 3 unioned with 3 to infinity. That's my domain. Okay, all I did was take that denominator, I guess I should just do it like this, and set it equal to 0. Okay, and all I'm doing is solving for it and I'm excluding it. So that would be my domain, would be this answer here. Okay, now for the vertical asymptotes, remember, all you're going to do is solve the denominator. Okay, so when I solve the denominator, it's x equals 3. That's the easiest. Now your transformation means, remember, hippos seem really violent. Remember that? Okay, so what we want to know is from this little problem here, okay, was there any kind of horizontal change from this to this? Sure, there's a 3 and it says -3. So a -3 means it went 3 units right. Okay, you're not going to have a stretch or shrink, and there's no negative, so you're not going to have a reflect. But you are going to have a vertical, and that's going to be that +5. So it's going to go 5 units up. And there we go. That's going to be your transformation. So for the bonus, you're going to have domain, where you're going to solve the denominator and exclude what you find. Vertical asymptote, where you're going to solve for it, and that's what it's going to be. And then you're going to have your transformation. Okay. Okay.
Is that like what's that in the middle? Oh, top of the.
Oh, I just X'd it out. Yeah, I said that that's not included. So we just don't want it. Yeah. So this interval would be -infinity to 3. And then 3 to + infinity. And that just tells us that we're excluding the 3.
Oh. And that's the domain.
That's the domain. Then your vertical asymptote is just x equals 3, because that's solving the denominator. And then your transformation is just going to be, we went 3 units right, because that's why it's the -3. and we went 5 units up. That's the +5. So we just did a transformation there.
Why would it be right? I thought it would be left.
Because when it's minus a number, it goes right. And when it's positive a number, it goes left. It's the opposite of what you think for the horizontal.
Oh, the horizontal.
Mhm.
So, 3 units. Right.
Uh-huh,
And it's like negative.
exactly. If it were x plus 3, then it would be 3 units left.
And then 5 units. Oh,
Mhm.
5 units.
Exactly.
Okay. So
That one makes sense. There you go. Okay, the last one I want to do is I want to go back and do number 24, just in case people want the bonus for it. Okay? If you want to get out your stat stuff, you can, or you can learn the bonus if you want to do the
I wanna
bonus.
learn the bonus.
Okay, let's learn the
Just in
bonus.
case.
Perfect. Okay. So remember, what's required are those steps from the back. But if you want to do the bonus, here's what we're going to do. We know that we're going to have 3 answers. Okay. So first thing we're going to do is the rational zero theorem. So we're going to have to come up with factors of 12 and factors of our leading coefficient, which is 1. Okay. So factors of 1 is just 1 and 1. Yeah. Okay. For 12, though, there's going to be a lot. You're going to have 1 and 12, 2 and 6, 3 and 4. Yeah, you're going to have a lot. Okay. So these go in the top. Factors of the constant go in the top. So we're going to do plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And then in the bottom, luckily, we only have plus or minus 1. Now we're going to clean this up a little bit. And if we just divide each one of these by 1, they're all the same. So it kind of turns out nicely. Those are your possible zeros. These are your possible zeros. Okay. So then the next step is that we're going to have to start trying these until we can find one that does not have a remainder. That's what we're going to want to do. So let's just try +1 first. We're going to try him in the shelf. We're going to do synthetic division and see by chance if he does not have a remainder, because we don't want.
And then we have to write 1, 2, 11, and 12 out.
Say that again.
We have to write 1, 2.
Yes, good. Sorry, 1, -2, -11, and 12. Yes, we want our coefficients. And we're going to test it. We don't want a remainder. Okay, here we go. 1 times 1 is 1. Add that, gives me -1. 1 times -1, -1. We add, we get -12. 1 times -12, 12, we have a 0. Good, so we do not have a remainder. This means
There's 1.
that 1 is an answer. Good. Now, if we had come up with a remainder, we would have had to just scratch that and try another one. We could have tried -1, or we could have tried 2, or we could have tried something else. We have to find 3. But the good news is, by doing this, we have knocked down the poly to a quadratic that we can factor. So we don't have to do this again. So what we're going to do is write the answer. We were x to the 3rd. So now we're going to be x to the 2nd. So our new poly is x to the 2nd minus x minus 12 equals 0. Okay, I'm going to go ahead and write my little answer bracket down here. We know we want 3 answers, and we know 1 is already one of them. So we can go ahead and throw him in there. Okay, now I'm going to take this poly that I knocked down, okay, and I'm going to factor him. And he's going to be easy to factor because he's a monic. So I want factors of -12 that are going to add to give me -1. We could use 4 and 3, but we want a -1 when we add. So who gets the negative? Good, the bigger one. So good. Okay, now we're going to solve, and we get x equals 4 and x equals -3. And there they are, and you're done.
Oh, I thought we were gonna have to keep doing this.
Yeah, no, you're good. You're good. And then
It's
you're all
not
finished.
that hard, like you said,
It's
the
not.
longest process is the possible zeros.
That, yeah, and then picking one that, doesn't
Mhm.
have a zero. If we had picked two, or three, we would have been in trouble because we would have had to keep trying another one.
Would
But
it be
that is it.
would it be